Good morning, class. How are you today? It's a good? Okay, great. I think we can start now. Assalamualaikum warahmatullahi wabarakatuh. Om Swastiastu, Salam Om Nama Budaya, Salam Sejahtera, Salam Harmoni. Okay, before we start our lesson today, it will be better if we are praying together. Who has lead the prayers? Okay, Johnny? Good, Johnny. You can start the prayers. Okay, thank you, Johnny. Let me check the attendance. Who isn't here today? Bella? What's wrong with Bella today? Oh, I hope she is okay. Okay, now show your book and stationery to the camera for all of you. Okay, good, Feby. Arida? Good, Arida. Miguel, can you show me your books and stationery? Okay, good. Riris, where is stationery? Okay, good job, everyone. Okay, let's begin today's lesson. Today we will learn about factor. Who can explain about factors? Nobody was explained? Okay, it's okay. Please pay attention to me carefully. This is a video to learn about factors. Happy to study.
What is vector? Vector is physically quantity that has both direction and magnitude. In other words, the vectors are defined as an object comprising both magnitude and direction. It describes the movement of the object from one point to another. The below figures shows the vectors with head. This is a head, tail, okay, direction and magnitude. Okay, next is magnitude. The magnitude of a vector is the distance from the endpoint of the vector to the origin. In a word, it's a length. To calculate the magnitude vector A, we can use the Pythagorean theorem. This Pythagorean theorem is x square plus y square is equal to z square. Suppose we want to calculate the magnitude of the vector A. Okay, this is a vector A is 4, 3. This vector extends 4 units along the x-axis. Okay, this is 4, 4. And 3 units along the y-axis. This is for y. The magnitude of a vector is scalar value, a number representing the length of the vector independent of the direction. So we try to calculate the magnitude vector A is square root of 4 square plus 3 square and is equal to 5. So magnitude of vector A is 5. Okay, next. To complement the magnitude, which represent the length independent of direction, one might wish for a way of representing the direction of a vector independent of its length. For this purpose, we use unit vector, which are quite simply vectors with a magnitude of 1. A unit vector is denoted by a small caret or head above the symbol. For example, represents the unit vector associated with the vector. To calculate the unit vector associated with a particular vector, we take the original vector and divide it by its magnitude. In mathematical terms, this process is written as a hat is equal to vector A for magnitude vector A. So unit vector is a vector of magnitude 1. Unit vectors can be used to express the direction of a vector independent of its magnitude. Now, in the case of dividing a vector by a scalar, we arrive at a hat is equal to 4, 3 for magnitude 5 is equal to 4, 4. This is 4, 4, 5, comma 3, 4, 5. As shown in red in the figure, by dividing each component of the vector by the same number, we leave the direction of the vector unchanged, while we change the magnitude. If we have done this correctly, then the magnitude of the unit vector must be equal to 1. Otherwise, it would not be a unit vector. We can verify this by calculating the magnitude of the unit vector. So this is magnitude a hat square is equal to 4, 4, 5 square plus 3, 4, 5 square. And it's equal to 25 4, 25 is equal to 1. So magnitude a hat is 1. So we have demonstrated how to create a unit vector that has a magnitude of 1, but a direction identical to the vector. Taking together the magnitude and the unit vector, we have all of the information contained in the vector, but nearly separated into its magnitude and direction components. Okay, next is vector addition and subtraction. Vectors can be added and subtracted. Graphically, we can think of adding two vectors together as placing two line segments end to end, maintaining distance and direction. An example of this is shown in the illustration showing the addition of two vectors and to create a third vector is vector A plus vector B is equal to vector C. We add vectors component by component. That is to say, we add the components together and then separately we add the components together. For example, if vector A is 4, 3 and vector B is 4, vector B is, this is a mistake, vector B is 1, 2. Okay, then for addition, vector C is equal to vector A plus vector B. We add the component together, 4, 3 plus 1, 2 is equal to 4 plus 1, 3 plus 1. So we have vector C is 5, 5. Similarly, in vector subtraction, vector C is equal to vector A minus vector B. Okay, we add the components together, 4, 3 minus 1, 2 is equal to 4 minus 1, 3 minus 2. And we have we have vector C is 3, 1. Okay, next. Vector dot product. Okay, let's talk about the definition of what a dot product. Vectors in a plane has two components. They have a horizontal component and vertical components. So for our first vector is U. You could see that it has two parts. It has horizontal component and it has a vertical component. And I have another vector is V with the same thing. It has a horizontal component and vertical component. Now, according to this definition, the way we calculate a dot product is fairly you take the product of the horizontal component. This is a horizontal component, and you take product of the vertical components, and then you find the sum of those products. Okay, how to calculate the product with this example? This is, I have two components. We're going to find the dot product of vector U and vector V. So multiply the horizontal is 5 and 3. And the multiplied, the vertical component is -2 and 7. So vector u times vector v is equal to 5 times 3 plus -2 times 7. So, and find the sum. So here I'm gonna get 15, and here I'm gonna get -14. And so that has a dot product that's equal to 1. Okay, next is, the next is vector cross product. I'm now going to show you to calculate the cross product. This is the way that most people who calculate cross product do it. I'll do it with an example. Suppose you have two vectors, A and B, written as such, and you want to figure out, you want to figure out A cross B, which is equal to C. So what you have to do first is construct a matrix, and the matrix looks like this. This is a matrix. So you make a bar. This is a bar. And you're going to arrange I hat, J hat, and K hat in the top row. And then the components of A, this is a component of A. In the second row, this is the third row, X, Y, and Z. And now what you have to focus on the I hat. This is a first row, you have to focus on I. Okay, this is a J hat. You're going to cross out the column and row containing the J hat like this. And you have A cross Z and C cross X. And this is will be C times X minus A times Z. This is for J hat. And the last is for K hat. Okay, this is you're going to cross out the column and the row, and you have A times Y minus B times X. Okay, so what you have, I'm sorry. Okay, let's start with the example. Okay, I have two component is vector X and vector Y. Vector S is 5i hat plus 6j hat plus 2k hat, and for Y, vector Y is I hat plus j hat and k hat. Okay, vector S cross Y, cross vector Y. Okay, first construct a matrix, and you're going to arrange I hat, j hat, and k hat in the top row, and then the components of A in the second row is 5, 6, and 2, and the component of this is a component of X, vector X, and component of YX in third row is 1, 1, and 1. So what you have to do is the first row, and you're going to focus on the one I had over here. Over here. You're going across the top, the row and column. So you have 6 times 1 is 6 minus 2 times 1 is 2. And for J head, you're going to cross the column and row, and you have 5 times 1 is 5, and 2 times 1 is 2. And then the last is for K head, you're going to cross K head, this column and row, and you have 5 times 1 is 5 minus 6 times 1 is 6. And so that will be this. 6 times 2 is 4 for I head, plus 5 times 2, 5 minus 2 is 3 for J head, and 5 minus 6 for K head. And vector x cross vector y is equal to 4i minus 3 4i head, 4i head minus 3j head and minus 1k head. Okay, vector x cross vector y is equal to 4i head minus 3j head minus k head.
Okay, guys, this is a vector. So today we have study or learn about what is vector, vector comparison, vector cross product, vector dot product. In vector is have a magnitude, line, and direction, and the other. Okay, before we finish this class, do you have any question? No? Okay, I don't think we got time to finish the next chapter, so we will continue the next chapter in next week. And you must to have homework, guys. And homework is, okay, let me check it first. Okay, your homework is to prepare to chapter 20. Okay, you understand? Okay, everyone, don't work too hard, okay? Goodbye.